Part C, hence find the stationary points of the graph of y equals 3x minus 6 over x brackets x plus 6. Well, we found the two values of k for where it's got two limits of k where it has no solutions in this region here. And we found the two values of k were equal to 1/6 and equal to 3/2. Now these are the y values. So this is presumably going to be the 1/6, the lower one, and this has to be the 3/2, the higher one, because there's a region between which there is no solution. So this point must be lower than this point. But we've got those two y values, and now it's asking us to use those y values to find the stationary points on the graph. Well, those k values are the y values, so we now just need to find the x values for those stationary points. So we say at k equals 1/6, we can put that into our original equation for the curve. So we have 1/6 equals 3x minus 6 over x brackets x plus 6. Times and across, we're going to get x squared plus 6x equals 18x minus 36. Bring the 18x over, we're going to get x squared minus 12x plus 36 equals 0. And if we factorise our quadratic, we see it's got repeated roots, factorising to become x minus 6 squared equals 36. Minus 6 squared gives me plus 36, and two lots of x times minus 6 gives me the minus 12x, so it's correct. So our first stationary point is, solution to this is x equals 6, so our stationary point is at x equals 6, comma, y is 1/6. For our second one, we're solving for the second k value, which we had was 3/2. So at k equals 3/2, again we'll sub it in. 3/2 equals 3x minus 6 over x brackets x plus 6. Again, cross multiply, and we're going to get 3x squared plus 18x equals 6x minus 12. Bringing all the terms to one side, solving as a quadratic, we're going to get 3x squared plus 12x plus 12 equals 0. Divide through by 3, x squared plus 4x plus 4 equals 0. And again, note, you must get repeated roots for x. In this case, it's x plus 2 squared equals 0, or x equals minus 2. That gives us a point of minus 2, 3/2. So we'll write this down as our point, minus 2, 3/2. If we go back to our curve and quickly look, we can see minus 2, 3/2 is kind of in agreement with our curve, and similarly at x equals 6, we're getting y is 1/6. One last thing we should state for completeness is that here at 6, 0.616 here, we have a local maximum. We're seeing that from the graph, so we'll write local max by that point. Notice we haven't used the second derivative d2y dx squared to find out. We've just using it, seeing that from the curve itself. And similarly at the point minus 2, 3/2, minus 2, 3/2, this is a local minimum. So we might as well state that for completeness. Local min.